Okay, as far as the solids are concerned, we've talked about a couple different types of solids. The ones that we're going to focus the most on are polyhedra and solids of rotation or solids of revolution. Hey, let's look at polyhedra first. Polyhedra are solids that are formed only using polygons. There's two main classifications that we're going to, again, kind of emphasize in this chapter, and that is a prism and a pyramid. Okay, when you're dealing with prisms, okay, again, it's a polyhedra, meaning all of its faces are polygons. A prism is going to have two parallel and congruent bases. So whatever shape you have, so let's say we take a triangle. If you were to take a parallel and congruent triangle and connect it using, or connect all the corresponding vertices, with that you create your prism. And we can do the same thing with, let's say, a trapezoid. If we took a trapezoid and we drew in a second trapezoid that's parallel and congruent to it, connect all the corresponding pieces, you're looking at a prism. A pyramid is the same idea. You start with a polygon base, but this time only one. So let's say we take a square or a rectangle, and now instead of them meeting corresponding pieces of a similar or a congruent figure, these are just going to meet at one common point. Okay, so it's one base meeting at one common point. Okay, again, it could be any of the types of polygons that we've dealt with, including regular figures. You can use dashed lines to indicate a side or edge that is in the background if it helps you to imagine it. But when you're dealing with prisms and pyramids, a couple things to keep in mind. These parallel and congruent polygons are called bases. As far as what we're doing in this chapter, if you see the letter capital B, it's going to represent the area of the base. So in this first problem, this triangular prism, capital B is 1/2 base times height. In this one, capital B is 1/2 times the sum B1 plus B2, all times height, the height of that polygon. Okay, so be aware of that kind of distinction. Okay, in a prism, your lateral faces are going to be parallelograms, usually rectangles, but they just have to be parallel to each other, or parallelograms. And those are called lateral faces. And then if you see the letter capital H refers to the height of the solid itself. So the height of a prism is going to be the perpendicular distance connecting the two bases. And so those are the pieces that you need to be familiar with in that. In a pyramid, what you need to be familiar with is, once again, your bases are the polygons that intersect at a common vertex. Okay, so the vertex is the name of that common point. In this particular case, your lateral faces are triangles. So all of these lateral faces here are your triangles. Same here. Okay, and the height of your solid is still the same thing. It's the perpendicular distance from the vertex this time to the base. So perpendicular vertex to the base is still the height of your solid, and it'll be represented with a capital H once again. Okay, so that's what you need to be familiar with regarding the polyhedra. The other solids that you need to be aware of are cylinders, cones, and spheres. Okay, when you're dealing with a cylinder, it's very similar to the prism in that it has two parallel and congruent bases. So that's still represented by this black shaded region. The only difference is in a cylinder, your base is always a circle. The lateral face of this is an unrolled rectangle. And then finally, the height of this solid is the same as it was. The perpendicular distance between the bases is your height. For a cone, very similar. You have a circular base, one single base connected to a common vertex. The circle is still your base, and this perpendicular distance from the vertex to the base is again your height of the solid. Finally, a sphere. The one measure that you will have in place for a sphere is the radius. Okay. And that's true for all the solids of rotation will involve a measure of the radius. But in a sphere, that's the only measurement that you are looking at. Okay. As a reminder, a cylinder is created by taking a rectangle and spinning it around an axis of symmetry. A cone is a right triangle, spinning it around an axis of symmetry. And then a sphere is a semicircle, spinning around an axis of symmetry. And in addition to these, there is kind of an offshoot of a sphere, and that is a hemisphere. A hemisphere is just half of a sphere. So if you took a sphere and cut it in half, you'd be looking at a hemisphere. The radius would also be the only measurement involved in that figure. Okay, so that's just terminology-wise. It should all be review. We've talked about this, although we talked about it back in Chapter 1. Okay. For the most part, the types of solids that we're going to be dealing with will be right solids. All of these are examples of right solids. In prisms and cylinders, the bases are directly above each other. In pyramids and cones, the vertex is right over the middle of the base. But if you recall from our work with triangles or angles, oblique means non-right. So an example of an oblique cylinder would be one that looks like this, or an oblique cone. Those are just the two that are easiest to kind of illustrate. But when you're looking at these, the heights still fit the description here. It's the perpendicular distance from base to base, or it's the perpendicular from a vertex to the opposite base. The only difference is here the centers of the bases don't line up. Here the vertex is not over the center of the base. Whereas in a right solid, those centers would be lined up perpendicular to each other. Again, the majority of what we'll do in this chapter will be dealing with right solids.